In this video clip, let's look at the definition of derivative. Why do we need to study the derivative? One of the reasons from mathematics is we need to find out the tangent line for a curve. For example, we have a f of x equals x squared. Then there's the parabola. How we are going to find out the tangent line at 1, 1, this point? Before we do that, let's look at this animation. From this animation, we can see is that the rise delta y is caused by the run delta x. So we know delta y over delta x, you see delta y over delta x is the slope of this secant line, this red line, rise over run. Okay, so let me play few frames back. You see, when the delta x is 0.5, then we will have this point 1.5, this point 1, so the increment is 0.5 for the x variable. Then the increment for y will be, you plug in, here is 1.5, you plug into the equation, 1.5 squared minus, here you plug in 1, x is 1. Okay, we know 1 squared is 1. So you know the increment for y is delta y, denoted by delta y. Then we will have a rise over run is 1.25 divided by 0.5, which is 2.5. That will be the secant slope of the secant line when we will have one point here, another point here on the parabola. And you know, when the delta x gets smaller, the increment gets smaller. You see, when the increment of x is 0.2, then we know this point will be 1.2. You plug into the equation, here will be 1.2 squared minus 1 squared. We'll get increment is 0.44. So the increment for y is delta y, which is 0.44. And then this 0.44 for the increment of delta y over delta x, which is 0.2, rise over run is 0.44 divided by 0.2, which is 2.2. It looks like when the increment gets smaller and smaller, the rise over run from 2.5 to 2.1. It appears that possibly the slope of tangent line might be 2. you may plug in even smaller increment amount of delta x, and then find out delta y and choose the ratio. Okay. So then we know the increment actually is calculated by this formula. Okay, you see the increment delta y is like this, calculated in this way. When delta x is 0.1, you plug in 0.1, here is 1.1 squared minus 1 squared. This is delta y. Okay, so basically the formula is right here. There's the delta y, and here is delta x. Then you know by the FOIL method, we can FOIL this one out. 1 plus delta x squared is 1 squared plus delta x squared. Inside, you know, the inner product and the outer product are the same, so we double it. Okay, once we double it, here we have a 2 times 1 times delta x. Then subtract this 1 squared. We will have this will be the delta y. This will be the delta y. So then we have a 1 squared cancel each other. And then we have a delta x cancel this delta x squared. We cancel this delta x again, so we get is 2 times 1. This delta x is cancelled. Delta x squared cancelled with 1 delta x, so we have that. Okay, so actually the rise over run can be calculated in this way. You see, when delta x is 0.1, 0.1 plus 2, 2 times 1 is 2, so then you have a 2.1. Okay, so when the delta x is 0.2, 0.2 plus 2 is 2.2. So basically the rise over run, the slope is this formula. Okay, is this formula. Okay, then you know if we let this delta x approaches 0, then we will have at the limit, which is 2. So when delta x is very small, and then when delta x approaches 0, we will then have the slope for this when x equals 1. We can find out the slope in this case, which is 2. Okay, so then after we get the slope, we use point slope form. That will be 1 subtract 1, y subtract 1 equals 2 times x subtract 1. So then the function can be simplified to y equals 2x minus 1. This will be the equation of this slope. Okay, so when x equals 0 from here, you can see 2 times 0 minus 1 is negative 1. So 0, negative 1, 0, negative 1. So this point is on the red line. When x equals 1, 2 times 1 is 2 minus 1 is 1. So 2, 1 is this point. So you can see the equation of this one is the tangent line. The slope is 2. Okay, so here is that we need to find out the slope of tangent line at a certain point. It drives a need. We need to find out the derivative. So the derivative is what? Is rise over run. Choose the limit when delta x goes to 0. Remember, delta x goes to 0, delta x can never be 0. It's possible delta x can never be 0. Okay, so then we use this way to get rid of this denominator delta x be 0. We then find out the limit. Okay, this limit will be defined as the derivative of function y equals x squared at the point x equals 1. So what is the derivative? Derivative is actually the slope of the tangent line. Okay, that's the derivative. All right, so here is that we find out the derivative at x equals 1. For the special function f of x equals x squared. We may replace this one with x, because you can see all here are 1. We can replace this by x. So this line will be the general definition for the derivative. This one. F prime of x means the derivative. So for a general function y equals f of x, the derivative is denoted by f prime of x, is defined it as the rise over run. Okay, upstairs is the rise, downstairs is the run, and I choose the limit. Okay, for this special function, then we shall have a what? We shall have the derivative is 2 times x. So what is the derivative for f of x equals x squared? The derivative for f of x equals x squared is 2 times x. Okay, so that's the definition of derivative for f of x at any point. And if you want to define a special point, okay, that's f of x at a special point is defined in this way. Okay, and for this special function f of x equals x squared, then you can keep going in this way. Okay, of course there are different functions, so starting from here, you may treat with different functions if you are giving a different function. Then we'll talk about this, in the following lecture. All right, I'll see you next time.